Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, how are you? Hopefully this video finds you well and you're ready to start watching this video. In this video, you will learn about a guest behavior. The learning objective for today is describe qualitatively the pressure and temperatures of a gas in a term of its motion of its particles. Before moving forward, let's make a quick review for your last meeting topic. In the last meeting, we have learned about the three states of earth. What is the first one? Solid. The second one is liquid. And the third one is a gas. Because we were talking about a gas behavior, so let's focus talking about a gas first. In the last meeting, we have learned about a gas properties. I need you to remember about what is the difference between the gas properties with the other states on Earth. You have to imagine about the distance between each gas particle. Gas is a state of matter that's hard to imagine because you cannot see it by your naked eyes. But even if we cannot see a gas particle, we can prove the presence of a gas particle by observing the behavior of it. Let me give you one example. For example, I spray a perfume in a corner of the room, but I can smell it in the whole height of that room. That is one example or a gas present in our daily life. I need you to also think about the proof of the presence of a gas particle. You may mention it out loud. Wow, very good. Yes, that's correct. Okay, so let's talking about the other properties of a gas. If we change the pressures and the temperatures, and let's see what will be happen on the gas behavior. So let's discuss about that one. I will show you a simulation so that it can help you to imagine the gas behavior due to the effect for the temperatures and pressure. So that without further ado, let's start our session by reciting Basmalah all together. Bismillahirrahmanirrahim.
Okay, talking about the gas behavior, it's important for us to know about the kinetic theory. Kinetic refers to movement. The kinetic theory states that submicroscopic particles of all matters are in constant and random motion. The kinetic theory is a unifying concept that uses the idea of moving particles to explain gases, liquids, solids, phase changes, and the effect of temperatures and pressures on this. So, the gas particles need an amount of energy to move from one place into another place. We name that kind of energy as a kinetic energy. So, we will relate the kinetic energy with the gas behavior due to the changes of the temperatures and pressures. Let's move to the simulation. In this simulation, we have two types of particles, the blue one and the red one. And let's see how many times they collide with each others when we change the temperatures and pressures. We can see it from the numbers of wall collision. So the numbers of wall collision here will represent to the kinetic energy of it. When they have a high numbers of wall collision, it means they have a high kinetic energy. And so the reverse version of it, when they have a small numbers of wall collision, they will have a low kinetic energy. And here we can set an aspect become a constant, so we can focus on our observation. Let's start to see the pressures aspect to the gas behavior, so that we have to make the temperatures in constant. You have to see right now the pressures is about 7 atmospheres, and let's count how many wall collision that they have. So you may taking a note. If the pressures is about 7 atmospheres, the wall collision is 47. Okay, let's try to count it once again to make it valid. So it's about 55. So yeah, let's take the 55 one. It's bigger than the first one. So when the pressure is 7 atmospheres, the wall collision is 55. Now I'm going to change the volume so that the pressures will be decreased. So now the pressures is 3 atmospheres, and we can compare the wall collision. Let's count what is the wall collision if the pressure is about 3 atmospheres. Okay, so here the wall collision is 38. So what's the result, everyone? You may compare. So we can get the conclusion. When we decrease the pressures, the wall collision become decreased also, right? So by changing the pressures, the kinetic energy will be decreased also. And when we increase the pressures, the kinetic energy here will become increased. We can observe it by the speed of the gas particles. You can see there, when we expand the volume, that makes the pressure become decreased, the gas particles speed is also decreased. They move slowly than the first one. You can see again, let's make it become increase. The pressure is increased, and then you can observe, oh, the particles will move faster, so that we can see that they increase their kinetic energy. Okay, so that's from the pressures. Let's move to the temperatures. We will change the temperature, so we will make the volume become constant. Okay, let's make it more big and set the volume is constant. Now the temperature is about 300 Kelvin. Let's count how many wall collision that they has. You may taking a note. When the temperature is 300 Kelvin, the wall collision is 47. Now I'm going to increase the temperatures. Let's make it become 1000. You can see there, the speed of the gas particles is also increased. Let's stop when it is 1000. So yeah, the temperatures right now is 1055 Kelvin. You can see it's very fast, right? The movement of the gas particles is become faster than before. And let's count how many wall collision that they have. Let's see, it's increased. It's become 87. So it's related with the pressures, right? When we increase the temperatures, the speed of the gas particles is also increased, because when we give an energy, when we increase the temperatures, it means we give an amount of energy to the particles. So the particles accept that amount of energy to move from one place into another place, so that they will have a high kinetic energy when we increase the temperatures. The same reason, when we decrease the temperatures, the gas particles don't have a lot of energy to move from one place into another place, so that the speed becomes slower than before, and then they will have a low kinetic energy also. So that's the look of the gas when we change the temperatures and pressures. So now you know the reason, for example, when it is raining, when the temperatures is cold, you prefer to not do anything. You prefer to laying down on your bed. That's because the kinetic energy is decreased when the temperatures is decreased. See, chemistry can explain everything. Okay, so that's for today, everyone. Let's go to the closing session.
Okay, so that's it for today's everyone. Before we end the session, let's make a summary. Due to the effects of the temperatures and pressures, it changed the kinetic energy. If the temperatures increase, the kinetic energy will be increased. If the temperatures decrease, the kinetic energy will be decreased also. If we change the pressures, if we increase the pressures, the kinetic energy will be increased, and if we decrease the pressures, the kinetic energy will also decrease. How is everyone? It's simple, right? Yes. So that's it for today's discussion. If you have a question, do not hesitate to ask me. Let's close our session by reciting Hamdalah together. Alhamdulillahirabbil alamin. Thank you so much for watching this video. Bye-bye everyone. Assalamualaikum warahmatullahi wabarakatuh.